and get a git clone of Praeda II. That looks good. So okay, there we go. And then we just change directory to Praeda. And here are the standard files that are downloaded from the actual Git, with the primary one being Praeda. Set it up so it runs. Let's go ahead and just run Praeda. Should get the syntax. And here are the general syntax of the actual tool. So we have the ability to actually run Praeda taking a standard mmap scan gmap as input. We can also do a target input file, or we can actually do a CIDR and feed a CIDR into the actual tool. So we're going to go ahead and demo a couple of these. The first thing we will need to do is actually run an mmap scan of the local network, and we have a couple printers on here, a Xerox and a Konica printer, that will show you some of the standard data that's actually collected for the most part. Okay, that finishes that up. So if we look at our output here, we have results. So what Praeda does, it'll actually crawl and take the input from the results file, looking for anything that's HTTP or HTTPS. And it'll go ahead and it'll test it, and it'll query it, see if it's a printer. Does it fit within the model that we're scanning for? And if it does, then it'll actually try to retrieve various data from there. So let's go ahead and take a quick look at that. Okay, so as we can see, Praeda specifies the GMAP with the -G, and we have results. And what we're going to do is use results. And then we have a -J, which is a project name. So where a project name is going to be generated, that'll be a folder. And then we'll run some tests, and the output will be tagged as test. We'll make it test1. Test1 in the output logs, which will be written into example1. We also have the option of .I. If there happens to be some known HTTP style ports identified because the system locks or crashes, because there is some weird ports out there that often get tagged as HTTP or HTTPS that are not. I'm not sure what mmap's doing, but the parser is unable to handle those. If you encounter those, you can go ahead and remove those and kind of do a rescan or a restart and get rid of those. But let's go ahead and run this and see what we get for results. So as it scans, it's parsing the GMAP file for port 80, port 443, 8080, or any kind of HTTP or HTTPS style port. And then it's making a query of it, looking for title page, SNMP data, server type, and it using that to generate a fingerprint, compare the fingerprint against our fingerprint log, which is in data, and then carries out several tests after that. So as you can see, we had some timeouts here on this particular device. This is not uncommon for some of the Konicas that may be in kind of a stand down mode or standby mode. If we core them again, they should show up. Often, sometimes you can actually increase the timeout. Our timeouts are moderate right now. I can't remember what they're actually set out, but you can actually set within the code. You can go out to the header in the code and actually increase the timeouts if you're experiencing a lot of this. Well, let's go ahead and rerun this. This time, let's go ahead and output it to test 2, see if we get kind of better results on the Konicas from our network. Okay, let's take a quick look at just the kind of the generic input output to the screen. So as you see, we kind of reran this, and the first one kind of brought the Konicas out of their standby mode, and we're able to get data here. So we just have some fingerprints in here that, in this case, some standard HP printers that it actually goes out and fingerprints on the network. Currently not set up to collect any data on those, just to do fingerprints. We have a lot more fingerprints than data collection, but as the product moves on and further, and we add more and more, it'll become more broader reaching. So the Xerox does an admin password check. In this case, instead of being admin 1111, which was common, some of them switched over to serial numbers. This will actually check for both, and here we came back and said, hey, the serial number of this printer. So we can attempt to retrieve the address books from this device. We can also look at the address books and determine whether SNMP is enabled within the address book, which is key security configuration that we may be concerned about. And then it does retrieve the actual address books and saves it out. So it saves it out to the file with the IP port, address, and a date timestamp. And if you notice, since we do run this with the GM map, it'll do port 80 and 443 on the same device. So we get some duplicate information in some cases. We also check to see if authenticated remote control is enabled or unauthenticated remote control is enabled. That is a function on a number of printers that act as if you're standing in front of the printer. All the features you'd have on the keypad or the touchpad on the front of the printer become available remotely. Often these have to be configured as admin to gain access, but they can be misconfigured, and that can be made available for all users, thus an unauthenticated remote control. And we check for that. We also check to see is LDAP configured. We may be concerned if you combine LDAP configuration issues along with default or weak passwords, that becomes potentially problematic for what is known as a passback attack. And that's generically what's put to the screen. Now, if we go to our example folder, we can see the output. Since we did run everything twice, we're going to see two tests, test 1, test 2. The first one I want to look at is, let's say, the address books. So we'll look at the second set of address books that were put out. So if we cat that, we can see the address books, and it's just general like usernames, email addresses, stuff like that may be of use to somebody doing a pen test or an assessment to see what kind of information we're actually potentially sharing to anyone on the network. The next one we want to look at is we're going to look at the web host. So if we cat test 2 web host, this is going to identify all of the web host data actually queried on the network, whether it was a printer or not a printer. And this is often useful for generating other fingerprints and other data collection mechanisms. Again, here's the Xerox. This one happens to be the Konica. Some of these Konicas are kind of weirdly named in some cases. And here's the HPs. And in one of our other videos, we explain this breakdown much more. But this data can be very useful for actually adding new fingerprints to the actual tool and identifying other things other than printers that may be on your network that may be of interest. And then the next one we want to look at is the standard output for the logs. This is a little more structured output. We have the device, we do the fingerprinting, identify what the device is. And this will do it for all ports. In this case, we have 80, 443, 8080. Here we do the Xerox, where we identify what it is. Identify the admin password that happens to be on the particular device. We actually pull the address books. We also validate the address books to see if they contain any configurations such as SNB is actually enabled. There happens to be an account set up on this device for a scan to folder, scan to file functionality, which utilizes SNB configurations. We also see we have LDAP services, and one of the things we're trying to do as we progress through this is identify more and more useful data. So like on the LDAP services, we can see LDAP username happens to be MFP services. The LDAP auth type happens to be simple. We also know if you're going to do a passback, you can use a Metasploit module. So we're hoping to put details in here moving forward containing what Metasploit modules may be able to be utilized against this output data during a test, an audit, and stuff like that. Here's the Konica. 1, 2, 3, 4, 5, 6, 7, 8, common password. We can see LDAP is enabled, MF services, auth type simple. Some of the output on these may be different. We still try to structure the information so it's somewhat usable. I think we need to add more functionality onto that particular command, as you can see. But that gives us the general concept of how this would actually work. So now that we've ran the GMAP example, let's just go ahead and do the target file example and see how that works. But the first thing we need a target file. So we know we already ran an mmap scan and it did the GMAP output of the local network. We're going to go ahead and just go ahead and parse this. So we have this list here. So let's go ahead and parse this and output it to a T-list, target list. How's that? Target list. And we'll go ahead and go -T list. We'll get the T list on there. In this case, we'll go port 80. And the job will be example 2, and the log file will be test1. Test1. Okay, there you go. So that went ahead and tested port 80 on the particular devices and brought back the required information from those particular examples. Again, we could also do a CIDR. I'm not going to run that here. Experiment with that. So if you want to do a CIDR, you should know what that is. You can target a network. This could be kind of slow because you're pointing at a lot of devices that may not have any ports open, and this product's going to test every one of them to see if there is a port 80 particularly open. So I always suggest doing an nmap scan and doing the GMAP output, even if it's just for port 80 or just for port 443. At least identify the devices. If you've already ran a larger port scan, you can go ahead and feed that in through the GMAP file into the device, use the -G switch, or you can go ahead and parse it for anything that's port 80, 443, 8080, or whatever ports you want to actually check for this. We also have the capability, as I mentioned earlier, to ignore ports. So if you want to ignore certain ports in GMAP that are tagged as HTTP, by all means put the port number in here. And we also have the ability, if for some reason the tool would actually hang or crash or do something like that, that you could actually restart it. And what this will do is it keeps a running tabulation of where we are at by comparing the log file and the output files and go, hey, the last one we entered was this IP address, start at the next one, and you can potentially restart everything with the -R switch and restart everything back up if there happens to be a problem you encounter. We plan on updating this on a regular basis. and we're always looking for input to help make the product better. So if you're interested in that, please follow our GitHub. If you can create something, put a pull request in there, we'll get to it and add it to the product. If you have any questions, reach out to us. We're here to help make this product better and kind of move it forward to get critical mass on it.